Hello, everyone. Thank you for coming. Waking up at 8 a.m. so early and coming to this presentation about Node.js security. My name is Ilya Verbitskiy, and I have been doing consulting in the banking, finance, and e-commerce sector for the last 10 years. And as you can imagine, information security is really important in those industries, and all security flaws cost a lot, and sometimes really a lot. You can lose your business if something goes wrong. First of all, let's take a look at those questions. Like, who has stolen my credit card? 2016 wasn't a good year for stores running on Magenta or OpenCard. There were some vulnerabilities allowing you to upload any PHP file to those e-commerce systems. And what happened was bad guys just created bots which which were looking for Magenta or OpenCard stores and uploaded keyloggers. So whatever credit card or NCV2 you typed on an infected website was stolen and probably stored somewhere in darknet. Is my blog secure? It's obvious that WordPress is platform number one if you want to build like simple website, blog, or some static content. And the truth is, WordPress is really, really secured nowadays. And the WordPress team reacts really fast if there is something wrong with the system. The problem is plugins. WordPress has thousands and thousands and thousands of plugins, and most of those plugins were built just in like 15 minutes hack or do it in a weekend, and developers didn't think about security. So there were another famous security issue in 2016 when there was an uploader plugin for WordPress, and it existed on the marketplace for years, and nobody really maintained it. And somebody found a security bug that you can upload any PHP file to WordPress, and imagine what may happen. The problem nowadays is hackers do not break just one particular website. They just run a botnet. They run scripts which just go through internet trying to find, infect your WordPress blogs, and then share some malware, whatever. And the last interesting news from last year, it was in the autumn, our internet actually was broken. There was a famous attack to DNS related to IoT devices. Everybody's crazy about IoT nowadays, so everybody's playing with Arduino and Raspberry Pi, and it's like really easy. Just buy a pack and build something. What happened was the bad guys built another botnet which were looking for web cameras, IP web cameras. And if you buy an IP web camera, you probably don't think about passwords and security settings. You just plug it in and it works. Right, cool. And most of those cameras came with really easy default passwords. And it was really easy to brute force and put some malware on it and attack. And imagine we have 100,000 IP cameras deployed all over the world nowadays. And what made the issue even worse was some of those IP cameras, they had the default passwords, but they didn't even have an interface to change the password. So imagine anybody can go to your camera and download your video or attack somebody. That's really scary. So I think that there are two major vulnerabilities in our world. The first big issue is our users, because it doesn't matter how much money and time you invest to building your information security system, how great your code is. If your user uses password 123, it doesn't really matter. Your system will be broken. And another bug is developers. So we as developers usually don't think about security in advance. We are trying to build our code as quick as possible to build an MVP product and go to market. And what happened next? We are getting popular, and boom, we are hacked. And in the worst case scenario, we've lost our business because lawyers cost a lot. And if you're working for finance, for example, then the thing is getting worse and worse because it's a highly regulated environment, and you will pay fees to government, to your customers, and let's take a look at this chart. This is the cost of bug fixing. When we are starting a new project, when we are gathering requirements and building the architecture, it's easy to prevent security issues in advance if you think about it from ground up. And the cost of adding security systems when we are gathering requirements and building architecture is minimum. It's not free, you have to spend time and effort, but it doesn't cost much. From the other hand, when you go to production and when your website is hacked or like your application is hacked, then your cost is unlimited. And because it really depends on your system. If you're a bank, then you're not just losing money paying the fees to government, but you also have reputation. You are losing your reputation, and it's very important. Like imagine I'm working with an internet banking of bank ABC, and they're hacked. What I will do tomorrow, I will go and close my account. So today we're talking about Node.js, and let's take a look to this question. Is Node.js safe? I think that Node.js is a unique product because it came to the market and grew up really fast, and it allowed front-end developers to do back-end job. So we actually invented developers called like full-stack developers who can do a front-end and back-end, and it's awesome. And business owners are happy because it shouldn't hire like 2 developers. They can hire as 1 guy who will do everything. And for front-end guys who are just coming to the back-end, they do JavaScript. JavaScript is a safe programming language. So we are safe here because we have a virtual machine and we cannot have like buffer overflow attacks and all these nasty things we remember from C++. And MongoDB and any other NoSQL database, we have NoSQL, so there is NoSQL injection. So again, we are safe. Everybody's happy. And then they say like Node.js plus MongoDB, it means safe application. Unfortunately, this is not the case. Today we will talk more about OWASP Top 10. This is one of those security checkbox lists which brings top 10 well-known vulnerabilities which are available probably like in all applications, unfortunately. There are other checklists, but OWASP was built precisely for web applications, and I think it's the most popular and most well-known. Current version was created in 2013, and it's used by NSA, CERT, PCI, European Union government, but by many organizations. And the next version is hopefully is coming next year, because they're trying to issue new checklist every 3 years, and like a month ago they finished gathering the information about the data leaks for the last 3 years, and now they're working hard to create the list and publish it. Let's get started. So the vulnerability number 10, which is not quite common but appears, it's called unvalidated redirects and forwards. Take a look at this code. You are building an authentication system, right? And imagine you have an authorized user who goes to your admin panel, and you want him to log in first and then redirect back to the page he requested. It's easy. So if you write code like this, and it's fine. What will happen if somebody sends you a link like this? If this code will be executed, that after a successful login, your user will be redirected to google.com, it's fine. But imagine you're building an internet banking app, and you have a phishing website which is gathering usernames and passwords, and the internet banking itself has this issue. So I send you a link and saying, hey, please check your account, please log in. You go to your internet banking, logging in, you know your username and password, so authentication succeeds, and then you redirect to malicious website where you see completely the same website, but saying, hey, your username and password was wrong. What you will do, type it in again, because nobody really checks the URL, what you have in the browser. And in this case, your account is compromised. What you can do, first of all, don't use redirects. Unfortunately, it's not the case. And if you have strict security policies, then you can use parameters like instead of redirects, so you can have a hash table saying 1 means admin, 2 means profile, 3 means whatever. And then instead of having the real URL for the redirect, you can use just these magic numbers. And if this is not the case for you, or you have time to build that, you can use valid URL npm package, which checks if the URL is actually your local URL and not a website. Number 9. Using components with known vulnerabilities. Again, this is a common problem. If you take a look to any more or less big Node.js application, it uses hundreds of npm packages, and every npm package uses another 100 of npm packages, and who knows what is there. The good news are there are databases available on the internet. Actually, it's also bad news, where you can go and check if your package or library you're using has some issues. So the place to go for Node.js is nodesecurity.io. This is a team who is gathering as much bugs and security holes in Node.js packages as they can. And they're really nice guys. So, for example, if you found a bug somewhere, please make sure you send them an email saying, hey, we found this security problem, please add it to your database. They also have a competitor called Snyk. And the Snyk, they are mostly focused on Node.js and Ruby on Rails. And there are also 4 other places to go, and there's also like general security information databases where you can find bugs for Apache and Nginx, Windows, whatever. And like this exploitDB is kind of cool one because it's not just the text information about what's wrong or that you have something wrong. It's also information about it has exploits, so you can download the code and play like a hacker and try to break you up. So you see, there is this problem, and it's really important to choose your NPM packages. So when I'm choosing NPM packages for my projects, I'm usually following this checklist. So first I check the popularity of a package, and if it's a version 0.0.1 and it has just 40 downloads a week, so probably I'm not going to use it. If there are competitors with more downloads, or they are longer on the market, then I'm trying to get information about the author. Usually have Twitter accounts, some GitHub accounts, you can see what they're doing. Then you can go to GitHub and check what's going on with the project, the popularity, like if it's active and in development, it has issues and authors are communicating with the community, this is a good sign because it means that somebody will probably find the security issues and hopefully they will be fixed. And if the project is dead 5 years ago, so then there is no point to use it. And or you take this risk and probably have to do like a code review and try to find out the way to use it, but it's a risk. Then, if projects use static analyzers and unit tests, that's great, especially like static analyzers, because it means that developers are really thinking about security and they have this security mindset. Then, if you have time, you can check public security databases, mailing lists, Slacks. So, and again, it's really depending on your application. So if you're building an internet bank, that's one thing. You're not going to use a package and be happy. And if you're building just another startup, for cats, then well, just use it because there is no value to hack your system, really. And this checklist is like really time-consuming. So that's why there are tools for Node.js which automate it. The one I like the most is NSP, and it uses Node security database, vulnerability database, and it's integrated with Go, Grunt, or you can run it as a console. What it does is just takes the list of npm packages from your package.conf and checks against well-known issues. And there are a few others like Sneaker-JS and JS Prime. Those are doing the same, but against different databases. So if you are really paranoid, then you can use 4 of them. There is a package for ESLint called scan.js. It's a static analyzer for JavaScript, and it tries to find the issues like JavaScript injection and some like coding things like SQL injection, and tell you about that. Of course, there are a lot of false positives, but you have to live with this, unfortunately. Rocky, it's another static analyzer, and it was built actually not to prevent you from having issues in your code, but to clean up the existing website. Imagine you have a WordPress website, right? And usually when it's compromised, then you have some viruses or some dummy JavaScript somewhere in the footer, and it's really hard to find it yourself. And especially if it's not just one website, if it's a hosting company, you have 100 websites. So what Rocky does, it has a database of well-known malware patterns, like some regular expressions and other things, and it just goes through all of your code base and tries to find some patterns and report it. And if you want to do some investment or buy some products, I know only one static analyzer, commercial static analyzer, which is available on the market, which works with Node.js. It's called VRCode, and it supports like all like a lot of languages like C++, like C#, Java, and they finally added Node.js. So if you know any other static analyzer which works with Node.js, please let me know. Okay, so we used all of these small tiny things. We hope we have the best NPM packages in the world. What may happen next? We have zero-day exploits. So those packages may have vulnerabilities which we don't know about. And somebody may find it and try to exploit it on our website. In this case, we can minimize the risk by using web application firewalls. The most common one is Mod Security. It's an open source solution which works for IIS, Nginx, and Apache. It has pretty big open database of security patterns or attack patterns. And there are a few others like IronB, NXC, Shadow Demon. Those are all open source. And if you are on AWS or you're using Cloudflare, they also have a packaged cloud web application firewalls in the system. So in AWS, just go and enable it. So, number 8, cross-site request forgery. Do you aware how this attack works? Okay, so like really quickly, we have a vulnerable application which you have a form to transfer funds, right? And what this form does, it just accepts parameters from two and checks if you are an authenticated user. If this form is vulnerable to CSRF attack, then a hacker may create an HTML page with an image tag. And the source of this image tag will be a GET request to your fund transfer form, something like send money to and from. Then he sends this HTML file to a legitimate user who opens it, and what happens? The browser loads the HTML, parses, he sees, okay, I have this call to transfer fund, and it calls it. And if the user is authenticated in this banking system at the moment, then his money will be transferred somewhere else. And surprisingly, this not too many developers know about it, still don't know about that, and I see it like quite frequently. Again, we can deal with that. There's a package called CSRF, and it's actually automating this CSRF attack protection. What you do is like quite easy to use. First of all, you register a middleware, CSRF, and then for your form, For each form, you generate a CSRF token. In this case, we store it in the cookie. And this token has to be in the form. What happens next? You have the form with this hidden field. And when the request goes back, it goes to CSRF checker first. And it compares if you have this unique token in your cookie and the same unique token in your request. So if they match, the request proceeds. Otherwise, it's blocked as authenticated access or security issue. Number 7 is missing function level access control. This is a really, really common thing because developers are lazy. First of all, it's quite common to use this security through obscurity. Imagine you have an admin and you don't want to build like authentication system. It's just for developers, like MySQL admin. What they will probably do, they upload it to a website and create some dummy name for directory ABCD123 and think that nobody will ever figure it out because, come on, you have to have FTP access to see that there is this hidden directory. The problem is bad guys have automated tools. We just go and scan your websites for common patterns. And surprisingly, we are all people and we use the same patterns. And we have really high chances that these hidden directories will be disclosed. Another thing is like checking permissions only in UI. Again, quite common. So you have your view and you check, okay, if I'm user as admin, is admin, then show him this button, otherwise don't show it. And then you have a post back request, and you don't check the permissions, really. It happens a lot because, you think, come on, if the guy cannot see the remove account button, then how can he call it? Again, automated tools will help you to do that. And missing permissions checks in helper services. Again, let's talk about e-commerce in this case. You have your store, it's like secure, protected, everything goes well, but you have a fulfillment service which deals with your ERP system and it's listening for MQ messages and does something. Imagine that somebody broke your system and he sends a package directly to this MQ, avoiding your front end, like your e-commerce website. And probably your ERP service is not checking permissions because he thinks, okay, if somebody is able to send a message to this MQ, then probably he is a legitimate user or our e-commerce system. Again, not the case, and it happens quite often that systems are broken through these things. What we can do, unfortunately, there's not much what we can do in this case rather than doing code review, testing, and probably punishment for developers. But that's life. And yeah, make sure we check permissions on all applications layers and you use authentication middleware everywhere. So just register that every single request goes through authentication middleware. And number 6 is sensitive data exposure. Things may go wrong. And we're all dealing with data. All applications are dealing with data. And there are 2 places where the data may leak. The first one is networking. You might be a government who can listen to all the traffic going through the country. Or you can be internet provider. Somebody can be, bad guys can work for internet provider and they can inject a sniffer in a router and listens everything. So this is one potential security issue. And another one is insecure cryptographic storage. Again, imagine things go really, really bad and hackers are able to download your database. And you are a store. What they will see there? Probably addresses, credit cards, CCV2 codes. And this information has to be encrypted. Let's talk about preventing sniffing first. Fortunately, it's easy to do nowadays. You must always use TLS. And yeah, even if your if you are not building a secure website, use TLS. And HTTP2 specifications were introduced a few years ago, and the good thing about it, it forces you to use TLS. It forces you to use encrypted channels. If you read the spec, the HTTP2 has a possibility to work over unencrypted channel, but all implementation I know just force users to use encrypted channel. And in the last few years, there were many issues found in SSL and TLS implementations. So now you should use only TLS 1.1 or higher because other versions are vulnerable. Moreover, if you're working in e-commerce sector, then probably you're aware about PCI compliance, and PCI is an organization which issues a set of set of rules, what you should do to make sure that your web e-commerce solution is protected. And since June 2016, they force everybody to use at least TLS 1.1, no matter what. And those protocols are supported in all browsers nowadays, so you are safe. And there are a few other rules. So first of all, if you deliver secure content, make sure it's encrypted. And if you're probably dealing with authentication and you're dealing with session cookies, and in this case, make sure that you use secure flag for those cookies. It means they are sent only over TLS. And you shouldn't mix secured and unsecured content on one page. Let's say if you're loading HTML page over TLS, and then you have a JavaScript loading over HTTP, what happened in the past, somebody can intercept your traffic and add some malicious code into your HTTP because it's like plain text. The good things, I think all modern browsers do not allow that. So when you're developing a website and you're going somewhere on HTTP, HTTPS, and there's a JavaScript loading on HTTP, probably your script will be broken, and in your debugging console you'll see, hey, you're trying to use unsecured content on secure page. So let's talk about data encryption. There are plenty of cryptographic libraries available for Node.js. Crypto is a built-in module. Actually, it's a wrapper, a JavaScript wrapper over OpenSSL, and it's quite performant. There's a library called SJCL. It's the library was built issued by Stanford, and they actually implemented the most common cryptographic algorithms like IS or some hashing algorithms. The good thing about this library, first of all, the performance is good. I tried that and it's pretty good. It's fast. Not as good as like native crypto module, but it's usable. And it runs in the browser. It runs on mobile devices. For example, if you're dealing with Cordova, and it runs on Node.js. So if you want to build just one piece of code and share it with like server and your clients, then give it a try. And yeah, there are a few other modules like Crypto.js and Node.forge. Those are just Node.js modules. You can take a look and if you're interested. And the good thing, W3C consortium created a specification called Web Cryptography API, and this specification is implemented I think in all major browsers nowadays. So right now you have native cryptography support in your browser, so you can use Crypto API from JavaScript. And again, it's optimized for performance, so it doesn't affect performance a lot. And if you are still using like old browsers, you can use Polycrypt. It's just polyfill for the Crypto API. Number 5, security misconfiguration. Yeah, that's a big problem, and it became a really big problem for MongoDB owners, actually in the last few weeks. If you heard the news that there was an attack against MongoDB, so somebody built a software which scans the internet and tries to find the open Mongos, because how do we deploy Mongo? just deploy it, don't even set a password. Or usually people forget even to set up like firewall rules to allow MongoDB connections only from your web app. So what this software is doing, if it finds an open Mongo, it downloads all the data, removes it, and then sends an email to the site owner, hey, if you want your data back, please pay us in Bitcoin. And people never learn. This happened, first time it happened in 2015. There were research when guys were able to find I think it was 30,000 open MongoDB databases without any passwords. And then the same researchers ran this test again in 2016. And then they found something 100,000+ open databases available on the internet. It was more like these digital ocean instances, so probably somebody played with it or was learning something. But it also was some major websites, surprising. And again, now in 2017, somebody thought, okay, people never learn, so let's make money out of it. There are several common security misconfigurations. First of all, default passwords and settings, and we also give too many permissions to our code. Yes, guys, please don't run your app as a root. Sometimes people do that. And information leakage, that's when, for example, if you're running an Express application, by default it sends an information that it sends an HTTP header saying this application is run by Express. So you just give information to the attacker that, okay, this is Node.js, so let's use Node.js attacks and don't scan for common PHP issues, for example. And I also add DOS attacks here. It is not misconfiguration most of the time, but sometimes it is. For example, if you don't set proper limits for your HTTP requests, somebody can send you 100,000 5 petabytes files, and probably your server is dead. Or another common issue are regular expression-based dangerous service attacks, and it works perfect for Node.js. So you can create a regular expression which actually calls an infinite loop, and since Node.js is a single-threaded server, you call an infinite loop for one request, and you're dead. Good things, we have tools to help us. First of all, I would highly recommend to start using tools like Ansible, Chief, or Puppet to automate your server's deployment, configuration, and all of these things. Because if you create one script and you have several people who can take a look to it and all your configuration in one place, it's a lot easier to find these misconfiguration problems. If you are building an Express application, then make sure one of the first packages you deploy after Express is Helmet. So Helmet is a set of middleware which adds some security-related HTTP headers to your responses, and for example, it removes this special header that your application is running on Express, and for example, it adds some HTTP headers which say to browser, okay, I want to load let's say JavaScript only from this domain name and block anything else, so it prevents you from cross-site scripting attack and something like that. So HPP, it helps you to prevent from HTTP pollution attack when somebody sends in URL you can send, let's say, parameter A multiple times with different values. And CORS, it's obvious it's dealing with CORS. And IP geoblock, it's a country-based firewall. So this middleware allows you to say, I want requests only from the US and I don't want requests from the rest of the world. Express limiter helps you to set up these request limits so nobody can send you 5 petabyte file and break your app. And safe regex, that's a library which protects you from this regular expression DOS attacks, and it checks that your regular expression is actually safe. And number 4. insecure object references. Again, that's another common issue in the code itself. Imagine you have code like this. You have a message ID. Let's say it's a Gmail. So you get a message ID from your URL, and then you query database and please give me my message and render this message. Again, so developer thinks that this code will be used only from the web interface, so they know what message IDs they can render in a table, for example. But somebody can create a request like this, message ID 1, and who knows what 1 means. And if message ID 1 is not assigned to your account, then you can read somebody's mail, which is bad. Okay, so what we can do, again, since it's a pure development issue, we have to use code review and testing. And the good practice is to use, if you have to send this sensitive information like message ID, it's better to pass it through session, like through cookie, not through the cookie, through the session, and do not show to attackers or to your users that you are using this special value somewhere. And again, check permissions on all application layers. But you must use code review and think what you write. So things are getting more interesting. Number 3. Cross-site scripting attack. I think it's very, very common, and everybody experienced it probably. And so, cross-site scripting attack is an attack when a hacker can add some malicious JavaScript code to your page, and when your normal users are coming, so first of all they can see like completely different websites, so they can do like deface your website with this JavaScript, or they can use some 0-day in the user's web browser and upload some exploits. That's actually what most of the hackers are doing nowadays. So they use cross-site scripting attack to spread viruses. There are 3 types of attacks. First one is like stored attacks. This is the attack when your JavaScript is stored in the database, and whoever comes to, let's say it's a bulletin board application, so you can store JavaScript in a bulletin board post, and then whoever goes to your website will execute this JavaScript. Reflected XSS is an attack when somebody adds JavaScript into your URL parameter. So in this case, somebody sends you a link, hey, please open this link, and then you will have a JavaScript inside your URL. Yeah, it's kind of easy to prevent. So those 2 attacks are not too complicated to prevent, and most of the web application firewalls are trying really hard to prevent them. There is a third thing. So our world is moving to the single-page apps where everything, even business logic, is done in the browser, and sometimes your browser is executing something and you don't even send requests back to the server. And DOM-based XSS is exactly this case. So imagine you have an XSS attack in your single web application, and it's not going back to the server, so it's somewhere in your browser. And in this case, you cannot use web application firewall to check your traffic, and you're screwed. So this is the most dangerous attack nowadays. Okay, the good news, we can prevent them. There are this is just more the most popular, 4 most popular libraries in Node.js to prevent XSS. It does doing some validation, and when you're doing validation, make sure you are validating based on content, based on the context. For example, if you want to use some text in your JavaScript, you must use JavaScript validator. If you think for CSS, then there's CSS validator, because the context is really important. Make sure you use HTTP only flag for your session cookies. because if the cookie is created with HTTP only flag, it sends only over HTTP and you can use it on the server, but JavaScript doesn't have access, so your session will not be stolen. And there is also Helmet CSP module, which deals with content security policy. And content security policy is actually HTTP header which says, okay, you can upload, you can execute your JavaScript files only coming from these domains and subdomains. You can load images only from those domains, and if you have a domain name and you applied content security policy, then it just will be blocked by browser itself. Number 2, authentication. Okay, so any more or less big application needs an authentication, and unfortunately, most of the time it's broken. There are a few bullet points how you can make your authentication more secure. First of all, it's like a golden rule: don't reinvent the wheel. There are plenty of authentication solutions available on the market, rather paid on open source. If you can use them, please use them, because it means that they are probably better tested, and there are a lot of users who are actually using them, and they report issues. So yeah, probably they're good, and most of the time they're better because this is just like one thing. Authentication must be over TLS, it's obvious, and sometimes I hear people saying, HTTP, because there is you can use HTTP authentication built into HTTP protocol itself. Sometimes you can hear, HTTP authentication is bad. Let's use form authentication. But the thing is, HTTP-based HTTP authentication is as good as your form authentication if you use TLS, because otherwise you will send a plain text no matter what. Make sure you have passwords policy, so that's more for users. So please ask your users to change the password at least once every 3 months. I know it's not so user-friendly, and probably they will hate you for that, but at least you'll be more secure. Secure error messages. It's a problem against it's a tricky thing to fix. Imagine you have a form and you type login name which doesn't exist in the system. Sometimes the good approach is to return a general error message like username and password is incorrect. What happens in the real life, you can see error message saying your username is not found or password is incorrect. What may happen in this case, this is an error message says too much to attackers. You can easily build a script which will brute force email addresses and check the error messages and find the real user accounts, and then you can do brute force passwords. Use two-factor authentication if you can. Right now there are multiple solutions available in the market. You can use Google Authenticator, for example, and it's easily integrated with Node.js or any other platform. And again, it's free, and it's available for iOS and Android, so easy to use. If you cannot use two-factor authentication, make sure you're using at least captcha. For example, if somebody is trying to log in and he tried 3 times and still unsuccessful, probably it's a brute force attack going on. So in this case, show a captcha and saying, hey, please verify that you're not a robot. And again, you can use reCAPTCHA to do that. And yeah, make sure you block accounts. And when you develop your restore password infrastructure, again, double check that it's secure, and because many websites were hacked because of issues in the restore password security, restore password infrastructure itself. The good practice is not to send username and password as an email, but usually when somebody tries to restore a password, you send him an email saying, please go to this URL, and you have like a huge unique ID, and then this page will allow him to change his actual password. Yeah, and make sure you don't send passwords, like plain text passwords in emails. There are plenty of modules in NPM related to authentication. Those are kind of the most important ones, let's say. So Passport. Passport is an authentication infrastructure for Express application. And so it's an infrastructure, and then it has some strategies. And right now it has 300 plus strategies. So it has strategy for Twitter, LinkedIn, Facebook, whatever. So yeah, I highly recommend you to use this middleware. Again, if you're using Passport, you can use Passport 2FA TOTP. And this is a strategy which works with Google Authenticator or Microsoft Authenticator or any other two-factor authenticator. And in this case, you can really easily build 2FA into your app. Just add 2 modules and do like a few lines of configuration. You're done. NOTP is a module which helps you to implement two-factor authentication yourself if you're building something from scratch or you don't using Express. Basic hours, it's a basic authentication. LDAP.js, this is a library which helps you to deal with LDAP, and it's getting, like if you're building a basic app, like app application, probably it's not too important for you, but if you're building an enterprise application, probably have an LDAP server to store your accounts and to store your permissions, claims, whatever, and you can use this for integration. There is also a passport strategy for LDAP, so it means if you're building an enterprise app, then you can just use this strategy and integrate with your enterprise infrastructure, and reCAPTCHA plugin, easy to add. Access control. So once you have your authentication, you have to think about authorization. And those are the NPM packages which helps you to deal with roles, users, permissions, and for example, I like the last one because if you are building enterprise app and you can store your permissions and claims in LDAP repository, so it's just one database when you have everything, users, permissions, and you can reuse the same accounts through all the enterprise. Okay, sessions. Since we are building a web app, we have to deal with sessions because we have to store somewhere an ID that this user is authenticated and we know him. There's also like check marks, what you should check once you're dealing with sessions in Node.js. So make sure that sessions ID are not shared in the URL because bad guys might find them in the logs. Use HTTP only flag, TLS, timeouts, and make sure like when the user is logging out or he closes the browser, your sessions really killed. We have to store passwords because authentications are all about passwords, and don't store passwords don't calculate an MD5 hash or SHA-1 hash and think that you're secure. Unfortunately, those hashes are compromised and they are not secure anymore. And there are multiple attacks to hashes itself, so you can use GPU or you can use rainbow tables to speed up the cracking process. So make sure at least you're using salt, so just add some random text to your password and then hash it. And use secure hashing algorithms like SHA-256 and 512. They are still secure, so nobody hacked it yet. And since there are more and more research going on in GPU and GPU are available, so like computations are really cheap now. There are these 3 algorithms like bcrypt, scrypt. The idea is those algorithms calculating hashes, but they're doing too many calculations and it's not easy to calculate. So for example, when you're using bcrypt, you can say how strong how many cycles you want to have. And for example, you can say, okay, I want to calculate hash in 1 second. So it means you will do like 1 second of calculations, and only after that you will have a hash. And imagine if you are doing a brute force attack against this cache, it might be complex. Okay, and number 1, my favorite, injections, all type of injections. So SQL, NoSQL, command code, whatever. So there are plenty of injections. Let's take a look to the most important one. JavaScript injection. This is attack, this command like code injection against Node.js. So imagine you have text like this. Sometimes happens, and somebody can break your website. How you can protect? Make sure you're using validation. If it's a SQL query, then you use parameterized queries. And if it's JavaScript, don't use those functions. At least don't pass text to those functions, because then otherwise you will have this JavaScript injection attack. And testing, use regular expressions, use all the development best practices. And one, command injection. So imagine code like this, and when you run it under the hood, Node.js will use your command, your shell to run ls command. So somebody can, if you write it like this, somebody can do whatever he wants in the system. To protect, make sure you don't use exec, or if you use it, you are you know what you're doing. You can use exec file or spawn functions itself. And again, validation, testing, code review, as always, with all these injection attacks. And that's my favorite one, file upload. So many applications were broken because of that. When you're dealing with file uploads in Node.js, probably you trust the library you're using. Unfortunately, somebody can go and create a raw HTTP request like this. So in this case, we just overwrite index.js with this small JavaScript usually removes everything from the server, which is bad. To prevent that, first of all, I would suggest to use Express file upload middleware. And the good thing about this particular library, it has a flag for safe upload. And in this case, you can provide a regular expression for like safe characters. For example, to remove like 2 dots and like slashes. And but it still gives you a meme type. And please don't trust meme type, because I can send you a JavaScript file and set a meme type as an image. And make sure you validate the file extension. For example, you can use whitelisting for whitelisting for only images and then block everything else. And yes, do not put upload directory inside your web application root. So it's better to put it somewhere in the other place. And don't use the files which you receive from the user. The good practice is to generate a GUID, some random file, and then just store it. And at the end, try it yourself. So here you can see the list of really broken Node.js apps. You can go download them and try to hack them. And most of them have some documentation. So, for example, especially this NodeGod is a really good playground. It even has a video tutorial. Let's say if you want to break authentication, you can do this. If you want to break cross-site attack, you can do that. So I think it's like a really good education materials. Any question? Yes?
Do you suggest that... Oh, thanks. Hi there, sorry. Did you suggest that the SHA family was acceptable for password hashing?
Well,
you're saying it's okay to use the SHA family?
SHA 256 and 512, not SHA 1.
Isn't it thought that they're too fast for password hashing because they're just brute forceable?
It is brute forceable, but it's better than it's better than nothing. First of all, make sure you're using salt. So in this case, it's kind of harder to guess what the real password is, even if your hash is broken. And then if you cannot use bcrypt or scrypt, because I think only PBKDF2 is kind of certified this hash calculation function. So sometimes you just cannot use it because of the industry regulation. And in this case, you can use SHA.
Right, okay. So the advice is use bcrypt, etc.
Yeah, use bcrypt if you can.
Right.
Or, for example, like bcrypt calculation uses some CPU. And for example, if you're running in a cloud, I know, like AWS or Google, and you're paying per CPU usage, it might be more pricey for you in the long run.
Yeah, I'm not sure that's a good justification. Though. Thank you.
Any other question? Thank you very much for coming.